All right, so 4-6, we're going to analyze isosceles triangles. What do you know about isosceles triangles right now? Two congruent sides, what else? At least, she said. Notice that she said the words at least. If you have two congruent sides, what else do you have? The base angles are also congruent, right? And the base angles are the angles across, or on the side opposite, I guess, of across from the side. It's a little hard to say that. All right, so here, if you missed it the first time, so there's your diagram of your isosceles triangle. Your vertex angle is created by the two legs. The two legs are the sides that are the same length. Your base angles are the angles across from the legs. So if this is the leg, the angle across from it, just draw a line to it. From this angle, that's the side opposite it. The side across from the vertex is always the base. So you should have that copied down someplace else in your notes, like 4-1, I want to say. But again, if you missed it, there it is again. So here's your isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. And I put in there that those would be the base angles. And the converse of this is also true. If two angles are congruent inside of a triangle, then the sides opposite those angles would also be congruent. When you use this theorem, because you can use it forwards and backwards, I want you to write out the theorem. So my point is, I don't want you to use an isosceles triangle theorem in your proof. And you'll see the book do that for the answers when you look online. Just know that you have to be more wordy than the book does. The book doesn't do a very good job at writing proofs. So this is the converse of that theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So those two say exactly the same thing, but your givens are different. Then we have a corollary, which we don't have corollaries all that often, but we've had this third one in this chapter. A triangle is equilateral if and only if it is equiangular. So the point of this is, if you can prove that all three angles in a triangle are congruent, then you can automatically go and say that it is an equilateral triangle through this corollary. And if on this one you wanted to say if all three angles in a triangle are congruent, then the triangle is equilateral, that's fine. You don't have to use exactly those words. All right, corollary 4.4. Each angle of an equilateral triangle measures 60 degrees. So this is something we already knew, but they're putting it in an official corollary so you can use it in a proof. Corollaries are just statements of fact. Alright, so then we're going to do an example using algebra. And so with isosceles triangles, you're either going to set two of the sides equal to each other or two of the angles equal to each other. They might give you the perimeter, might give you expressions for all three sides of the triangle, and then they'll give you the perimeter, and they'll ask you which sides are the legs. So then you have to take your value for x, plug it into each of the sides, and see which two sides are equal. Just because a triangle is sitting on a particular side does not mean that that side is the base. Alright, so then let's look at an example. Alright, so example 1. In isosceles triangle DEF. So the fact that they're calling the triangle an isosceles triangle, immediately your brain should engage and say, oh, that means that two sides are equal or two angles are equal. Angle D is the vertex. So that's telling you now which sides are the legs once you draw the picture. Is the vertex angle. If the measure of angle E equals 2x plus 40, and the measure of angle F is equal to 3x plus 22, find the measure of each angle of the triangle. So if you have a problem that is in word problem format, you need to do the four-step plan. If it's written in words, four-step plan. All right, so your let statement's your picture. So we're going to draw an isosceles triangle. They have labeled for us that D is the vertex. So I'm going to put D up top only because that's where I'm used to having the vertex. That means that these sides are equal if D is the vertex angle. And that means that these angles here are equal because those would be the base angles. And they gave you the measures for E and F. So instead of setting two sides equal, we're going to end up setting two angles equal because aren't E and F the base angles? So I'm going to put in my picture that E is 2x plus 40, and that's going to be in degrees, and then 3x plus 22. So what I want you to do is set up your equation to solve and answer the question. When you find x, are you finished Nope, you have to then answer the questions, you have to figure out what question's asking you. So share your answers with those around you. See if they have exactly the same as you. Talk, talk, talk. So your equation to solve should have been that you set them equal to each other, right? What'd you get for x? Got 18. Then what'd you do with that? Plugged it into each of these, right? What did you get when you plugged them back in?
76.
Now, I plugged them back into two of them. Why? To both of them. Why would I do that? Yeah, if I know they're supposed to be equal angles, even though it's extra work, I want to check my answer to make sure I didn't make a mistake somewhere along the line. I could have made a mistake when I was finding 18. And if I plug 18 in and they both don't equal 76, I either plug them in wrong or I solve for x wrong. So then I can go back and fix my mistake. So once I'm assured that they're the same, I added them together and subtracted them from 180, and did you get 28 degrees?
Yeah.
Okay. So then your therefore statement should be, therefore the measure of angle D is 28 degrees and the measure of angle E and F are 76 degrees. You cannot use an equal sign in your sentence. All right, so then we're going to do a proof. Can I take this away yet? I'll give you a couple minutes. We're going to do a proof involving isosceles triangles. So you're going to see a picture that you've seen before, but they're using the picture in a different way. You ready? All right, so here's your proof. Now, I'm not going to be able to get this whole proof up there at the same time because it's a longer proof. So make sure that you write down the given, the proof, and the picture. I might be able to write it in up there. We'll see. We'll write that first, and then I'll put the statements up. So this comes from page 224 of your textbook, done as a two-column proof. There are different forms of proofs. We tend to focus on two-column proofs in this class, so we're going to write it as a two-column. This time your proof statement is a little different. It's asking you to prove that triangle ABE is equilateral. What do you need to do to prove that you have an equilateral triangle? Yeah, you can prove that you have 60, 60, 60 angles, but you can't just say that you have 60, 60, 60 angles, then you'd have to prove that they're all equal, right? Because the definition of an equilateral triangle doesn't say that you have 60, 60, 60 angles. It says that all the interior, well, truly what it says is that all your sides are equal. So, really how I'm going to end up proving this is that I have 3 equal sides. Is it true that equilateral triangles also have all equal angles? Yes. The true definition says that I have all equal sides. When I reveal the statements, don't write them all down at once. Write them down as I go through the proof, because otherwise we'll be here all day waiting for you to write it down. But I want you to see the statements so you can see the progression that we're going to take the proof in. But first we're going to mark up your picture. Part of it I've already marked up, right? The first thing that they gave you in the given was that segment AB is congruent to segment EB. So I got tick marks here and there. So right now I could definitely say that it's an isosceles triangle, just based upon that. Then it goes on to say that angle DEC, so follow your fingers, DEC, that's that angle there, is congruent to angle B. So that's why I have angle markers there. Are both angle markers, the arc marks, in the triangle that we're trying to prove is equilateral? No. But what else, just looking at that picture, could you prove? Before I show you the statements, what else could we prove? Jade? These are both congruent. Why? They're vertical angles. So that would get this angle here congruent, right? Then, just look at that triangle. If we know that that's equal there, what else could you say? To angle E, right? Why? If 2 sides of a triangle are congruent, we just have this one, 2 sides of a triangle are congruent, aren't the angles opposite those sides congruent? So these would be the base angles of that triangle. So now I've proven that these are congruent. I've proven that these 2 are congruent. If I can prove that B is congruent to E, probably through the transitive property, then I can prove that all 3 angles are congruent. If all 3 angles are congruent, can't we say that all 3 sides are congruent, therefore we have an equilateral triangle? Because one of our, let me flip this. One of our corollaries said that a triangle is equilateral if and only if it is equal angular, so I could use that in here as well, right? Okay. All right, so let's look at the statements. So I'm going to move this up as high as possible. Okay. Don't write all the statements down. Don't do it. All right, so let's go up here. So I'm going to start with my given, right? And I split my given up. So I started with AB, side AB is congruent to side EB. Why? Given. Then I used angle A is congruent to angle AEB. Angle A is congruent to angle AEB. AEB, this one here. So for right now, I'm going to go ahead and make those double arc marks just for right now because I don't have a connection to angle B or angle DEC. What was our reason for that again? If 2 sides, right, we just had this, if 2 sides of a triangle are congruent, then what? Then the angles opposite those sides are congruent. Okay, I use double arc marks for a reason. So now I've proven 2 of the angles in the triangle are congruent. I have to connect them somehow to angle B. So look what happens next. Angle AEB, that's this one here, is congruent to angle DEC. So I'm going to add another arc mark to DEC. Why? How are these 2 angles congruent? All right, so we're gonna write vertical angles are congruent. And the reason why I related these two angles are because in my given, don't I know that those are equal? So look at the next one. Angle DEC is congruent to angle B. Where'd I get that from? Where did this come from? Given. Don't forget about it. So step 4 is our given. So now I'm going to put a double arc mark there at angle B. So visually I see that all three angles are equal, but I haven't actually connected all three angles together. But I see I've got double arc marks on all of them. So look what has happened. This is equal to this. What we ended up with here, we start with here. DEC is equal to B. Logic says, if these are repeated, right, aren't these equal? Wouldn't this be equal to this? Is that what we wrote here? So AEB is this angle here, we're now saying is congruent to that angle there. So I have said, and before I talk about the reason why we can continue, what happened from here to here? What pattern is that? Is that the transitive property of congruent angles? So transitive property bless you. So now I connect all three angles together as being equal because of what came above here. Notice that A is congruent to AEB, and we've said that AEB is congruent to B, and so it stands to reason that A is also congruent to B. So we wrote them all together here. What do you think that would be? Say it loudly. Substitution property. It's not, I mean, the way we wrote it's not the transitive property, but we're connecting them all together. So substitution, and you have to write it all out, otherwise it looks like subtraction. So substitution property. So now I've proven all three angles are congruent. Notice that our very next statement is that angle AEB is equal angular. Wouldn't that be the definition of an equal angular triangle? Right? So 7, and I'm running out of room here. Hopefully the video will pick it up. So 7 is definition of equal angular triangle. And if a triangle is equal angular, what is it? Equilateral. And so statement 8 says if a triangle is equal angular, then the triangle is equilateral. If a triangle is equal angular, then the triangle is equilateral. A little longer proof. Not so bad though, right? A couple of things are new to you. This right here, having to make that connection. We cannot go from here to saying it's an equilateral triangle because the definition of an equilateral triangle doesn't talk about the angles. So we take the fact that the three angles are congruent and we can say it's equal angular, then any equal angular triangle is equilateral. So you have to be cautious of making jumps that you can't make in logic. Alright, so what should you do with that proof? Oh yeah, study it. Good job. Alright.